So let's suppose we have a good block cipher. How do we use it? Messages are typically longer than one 64 or 128-bit block. One straightforward approach is something called ECB, or electronic codebook mode. This is simple. We take our message M and break it into blocks, M1, M2, M3, M4. We encrypt each one individually, so M1 becomes C1, M2 becomes C2, etc. This is fast, because we can do them all in parallel, something great on modern multi-core processors. Assuming that our encryption algorithm is secure, then an adversary can't decrypt any block, and so our message is secure. Furthermore, we can reuse our keys, since every block encrypted with the cipher will be secure. Simple, fast, and secure. Nope, it's not secure at all. Using electronic codebook mode, an attacker will learn of repeated plaintext blocks. Since encryption is deterministic, then if M1 equals M2, C1 will equal C2. For example, if we're transmitting a sparse file, this is really bad, and an adversary could see where the non-zero regions of the file are. Here's a visual example of the problem using an image of tux. The center image shows the result of encrypting the image on the left with ECB. Identical regions of the image, such as the white space, show up identically, and you can see a general outline of tux. The image on the right is more like what we want, where there's no pattern and an adversary can't learn anything from the ciphertext. One way to achieve this desired degree of confidentiality is cipher block chaining, or CBC mode. In CBC mode, you choose an initialization vector IV, the same size as the block. You XOR M1 with this initialization vector and encrypt the result of that to produce C1. You then take C1 and XOR it with M2 before encrypting it to produce C2. If you want to use a key to encrypt only one message, then IV can be 0. The basic danger is that you don't want to reuse an initialization vector. Suppose you do. So you set IV to be 0 for one message, then reuse an IV of 0 for a second message. If the plaintexts are identical, then the ciphertext will be identical, and you've leaked information to the adversary. If we use CBC mode on the tux image, and we end up computing the ciphertext on the right, so problem solved. But again, for this to work across multiple messages and remain secure, you need to be careful about how you pick and use initialization vectors. Electronic codebook mode, cipher block chaining mode are just two ways to use block ciphers. There are many more with different properties, strengths, and weaknesses. Cipher feedback mode, for example, XORs the message with an encryption of the prior ciphertext. This is useful if the message isn't a multiple of the block size and you don't want to pad it with zeros. In ECB and CBC mode, you pass the message block to encrypt, so then you can't trim the ciphertext. Or there's output feedback mode, where you repeatedly encrypt the initialization vector and use it like a stream cipher. Or counter mode, where you encrypt incrementing values of the key and XOR them with message blocks. This is easily parallelizable, but means that you can only use a key for one message unless you do something smart with the value I. So let's do one final quiz. Suppose we have a shared secret key which only you and the other party know. You encrypt your messages with a good cipher using CBC mode and transmit those messages over a network. Are these messages secure?